So some ionic compounds have polyatomic ions, and the overall naming pattern is the same. We just need to have a name for the polyatomic ion. So remember, in Chem 1A, ionic compounds have two ions, one cation and one anion. There are things that do other things, but we don't talk about them in Chem 1A. So the names and formulas of the polyatomic ions just have to be memorized. If we look at this compound, NaNO2, we look at the first element, sodium is a metal. That tells us this is an ionic compound. There are two ions. So the first ion is the sodium, and you cover that up and you look at what's left. All of the things that are left are one ion together. We're not going to get creative and call that nitrogen dioxide or something. It's one ion, it's got a single name. It's nitrite. And it's nitrite because you memorize it, because that's what we decided to call it. Yes? Yes, please close those doors. So here are some of the common polyatomic ions, and I believe that all of these were on that list of things that you needed to memorize. Just like to point out a couple of them here. So this is carbonate, and this is hydrogen carbonate. It is also called bicarbonate, but carbonate is CO3 2-, and here we're adding a hydrogen ion, an H+, to that, and so there's an H here, and it changes the charge by 1. It's carbonate with a hydrogen on it, so it's a hydrogen carbonate. Here's phosphate, PO4 3-. If we add one hydrogen ion, we get HPO4, and now the charge is 2-. That's hydrogen phosphate. We can add one more hydrogen ion, H2PO4 -1, and now this one's called dihydrogen phosphate. This is one of the very few places where we'll see a prefix like that in an ionic compound. Over here we've got sulfate and hydrogen sulfate. And again, the same pattern, we're adding a hydrogen ion. This is also called bisulfate. We can do the same thing with sulfite. So there are patterns in here. My husband has a great pattern he swears by for memorizing the oxyanions, and he's shared it with me a couple of times, and I can't remember it for the life of me. And so then that makes me wonder if students would actually remember it, and so I've never gotten that one down. This is the only thing I can offer you. Nancy cleans cars and soaks potatoes. Weird, right? Nancy cleans cars and soaks potatoes. So these are the most common polyatomic, I call them the 8s. And the hard part to remember is what's the charge and how many oxygens, right? Because there doesn't seem to be much of a pattern. So just line them up like this. Nancy cleans cars and soaks potatoes. And then we've got 3, 3, 3. The first 3 are 3. And these 2 are 4. And then they pair up, minus and minus, 2 minus and 2 minus, and 3 minus. If that helps you, great. If not, forget about it. But one way you could use that is practice being able to write that down. And then when you get your exam, turn it over, and on the back, before you read any questions, which causes your brain to release all of its information, just write this down. You brought it in your head. That's not cheating. And then you're just writing yourself some notes before you get started on the exam. So these are all 8s. Nitrate, chlorate, carbonate, sulfate, phosphate. The first part's not hard. It's just part of that element's name, right? It's the rest of it that's tricky. So that's one way to memorize those. And I've mentioned before, sometimes we recognize I can't do all the things, right? Yes, I should be able to memorize all of these things and do all the homework problems and do everything in all my classes and work at my job and take care of my kids, and yeah, right. So you have to cut some corners, and then it's important to cut out the least important things. Like for me, that's dusting. Dusting does not happen at my house. Because if you wait, a few extra weeks to dust, is it really that much more difficult? No. Now dishes, that's another thing, right? You kind of have to keep up with the dishes and the laundry. So for polyatomic ions, these 5 here are really important because they come up a lot. There are some that were on the memorization list, like selenate and tellurate. They're not even on this list. You definitely could skip those and be fine. And even some of the ones on here, like chromate, that just doesn't come up very often. Okay? But these guys are super important. So most of those polyatomic ions are called oxyanions because they're anions and have oxygen. And there are some series of oxyanions. And there's a pattern in those series. So here's nitrate and nitrite. The charges are the same, and the numbers of nitrogens are the same. It's just the number of oxygens that changes. Here we have sulfate and sulfite. And so let's look at this. Here we have a series of 4 ions for chlorine and for bromine. So this is the one you memorize, chlorate. Perchlorate, per is like hyper, it has 1 more oxygen. Like hyperactive children have more energy, right? Chlorite, this is the light version of chlorate. It has 1/3 fewer oxygens than regular chlorate. Okay? And then hypochlorite. Hypo is a prefix that means less or below. A hypodermic needle goes below your dermis, your skin. So hypochlorite is 1 less oxygen than chlorite. So you memorize this one, and then you use the prefix suffixes here to make the others. So this is chlorate. Bromate is not on that list at all. But bromine and chlorine and iodine are in the same family in the periodic table. They're sisters. And so they behave in very similar ways. So here's chlorate, bromate, same number of oxygens, same charge, just change Br in for Cl. And so these all follow the same pattern, and we can do the same thing with iodate. Guess what the formula for iodate is? IO3 minus. So that's iodate. It's just like chlorate and bromate. And then per iodate, 1 more oxygen. Iodite, 1 less oxygen. Hypoiodite, 1 less. Yes?
I just have a question. Why is TE have 4 oxygens? Because I know that the phosphorus, sulfur, and the AS
Selenate?
has 4. I understand that part, but I don't know why TE has 4.
Well, tellurate is in the same family with sulfur and selenium. Yeah. And it's great if you can remember tellurate, but I struggle with that one. It just doesn't show up that often. My husband likes them in the memorization quiz because they fit well in his pattern that he does that I don't understand. So, yes?
When you say perchlorate, is the per just like an abbreviation of hyper since hyper means?
Yes.
Okay.
Yeah, it's a variant of hyper. Just, you leave the HY off. Why did they leave that off? I don't know. But in the English language, and especially in science, we do a lot with prefixes and suffixes. And they have relatively consistent meanings. And so then you can kind of figure out what the word means by knowing what the attachments mean, right? So here's my tricks, if you can call them tricks. Memorize the 8s, and then this pattern, only the number of oxygen atoms is changing. The charges stay the same. This is really a repetition of the previous slide, this part, and then this is my little notes on how to remember that one. This is upside down of how it's shown in the textbook. They put hypochlorite on top, and I prefer to think of it on the bottom since it's the lowest, but it's the same thing. Okay, so let's practice. Name this compound SnClO3 2. We haven't talked about this yet. There's parentheses in here. So there's a polyatomic ion inside of the parentheses, CO3. And I think of the parentheses as being a bit like shrink wrap. This is like a bundle pack at Costco where you buy the pickle relish and the mayonnaise and the ketchup and the mustard all come bundled together. You can't just buy the relish, right? You have to buy all of them together. ClO3, it's all 4 atoms together. You can't pick and choose. It's a unit, okay? So shrink wrap around it, and then on the outside is the number that says how many of those units are there. We could write it as SnCl2O6, but then it's hard to recognize that that's chlorate ion. If we leave the parentheses off, looks a lot like 32 oxygens.
So the subscript for 2 doesn't apply to the SN?
Correct. The subscript only applies to what's inside the parentheses. Does not apply to the SN.
How come the chloride in that doesn't have charge?
Well, the chlorate does have a charge, but the tin also has a charge, and they balance each other out. So in the formula for a compound, we don't indicate the ion charges because it would just be really messy and it's unnecessary. So a lot of this seems like really picky and like there's a lot of little rules. I challenge you to come up with a better system. This has been very well thought out. We're trying to be very consistent, follow patterns whenever possible. We're not writing extra stuff. And just so everything has one best name. Some things have other extra names, but there's one correct name for everything. So neither of these is very good. So when we look at this and need to name it, we need to recognize there's 2 ions. Okay, it's really tempting to want to split the chlorine and the oxygen, but there's 2. There's the metal and there's everything else, right? So writing a name, what's the name for the element with the symbol Sn? Tin. And then we ask ourselves, is tin in group 1A, 2A, 3A zinc or silver? It is not. What does that mean? Parentheses. It's going to need a Roman numeral. I don't know what it is yet, but I'm going to put the parentheses there to remind myself to come back to that. And then I look at this, and it's just what's inside the parentheses, chlorate. So it's tin something chlorate. Now we have to figure out what the charge is. So one way to do that is to go over here and draw out the ions. It says there's 1 tin and 2 chlorates. So I drew 1 tin and 2 chlorates. I know the charge on the chlorates. They're each -1. So I need to figure out what the charge on the tin is because the whole thing is neutral. So here I have a total of -2. I must have a total of +2 over there. There's only 1 ion for it to be on, so the tin must be 2+. Some people get that really easily, and some people really struggle with it. If you struggle with that, please ask me in class, in lab today. Ask me, and I've got a lot of other ways to explain it. You can get it. It's just one of those sidewalk across the Grand Canyon things. So the charge is 2, so the Roman numeral in here is 2. This 2 is not directly related to that 2, it's indirectly related to that. This is not necessarily any subscript in the formula. This is the charge on the tin ion. Okay? Any questions about tin 2 chlorate? Right, the formula for cobalt 2 phosphate. So writing the formula, we need the formulas of the ions. So cobalt 2 is CO, little o. We don't want to mistake this for carbonate or something. And the Roman numeral 2 tells me 2 plus charge. Phosphate. PO4, 3 minus. As you're doing homework problems in the worksheet, try to do it from memory and then look at the table and check yourself, okay? That way you'll learn them faster than if you always look them up. So now I've got my formulas with their charges. I have to figure out how do I put these together so that the compound is neutral. We could do crisscross. The 2 comes down as a subscript for the phosphate. The 3 comes down as a subscript for the cobalt. We could say, well, what's the least common multiple of 2 and 3? It's 6. So I need 3 of one and 2 of the other. Or we could do it more visually. So if I have one of each, I've got plus 2 and minus 3, and that's not going to work. I need more positives, right? So if I put in another cobalt ion, now I've got plus 4. Well, now I have too many positives, so I need another negative. So I can add another phosphate ion. Now I've got minus 6. And this seems like it's not really going anywhere. Just keep going. So I'll put another cobalt in there. Now that's plus 6. Oh, there we go. So 3 of these together give me positive 6, and 2 of those give me negative 6. If I put that group of stuff together, the charge will be 0. It's a neutral compound. So then in my formula, I'm recording how many of each of those I drew. So CO, there's 3 of them. And phosphate, there's 2. Phosphate's a polyatomic ion, and so I need to put the shrink wrap parentheses around it and put the 2 on the outside. If there's only one of the polyatomic ions, like something like sodium chlorate, there's only the one ion. It's not at all confusing. We don't need the shrink wrap. We leave the parentheses off. If you put parentheses there, I'll just scribble them out, but I won't count it wrong. And we never use parentheses for monatomic ions because it's also not necessary. Any questions? This requires practice. There are 2, what do they call them, dynamic study modules or something on Mastering Chemistry that will help you learn these. Those are for practice only. They're not assigned, but they are good practice for learning these. Hydrates are ionic compounds that have some water molecules associated with them. So here we have pictures of 2 different compounds. This is cobalt 2 chloride. This is also cobalt 2 chloride. This one's purple and that one's red, because this one has water in it. It's not wet. It has 6 water molecules in the crystal structure for every 1 cobalt 2 chloride formula unit. The water becomes part of the crystal structure. Wow, that's weird or bizarre or really interesting, and that's a whole nother topic, right, that you can go into. It is very cool. If we take this compound and we heat it gently, the water comes off, the color changes, and we get this. It's not as easy to go back. You can't just spritz it with water and have it go back, but you can make it go the other way. So these have names. We'll run into these occasionally. We're going to have just a dot here and 7H2O for magnesium sulfate. This is Epsom salts, which, your mom might have made you soak your sprained ankle in or something. Epsom salts or magnesium sulfate heptahydrate. This dot is a dot. It's not a multiplication sign. You'll have to learn how to write molar masses for these, and sometimes students want to multiply by 7 times the mass of water, and then you end up with this huge number. That's not a multiplication sign. It's a dot saying these two things are associated with each other. That's how we indicate a hydrate. So this one is cobalt 2 chloride hexahydrate. So we just use prefixes to say how many water molecules. This is the hydrate. When you are well hydrated, you have enough water in you, right? When you're dehydrated, you don't have enough water. Dehydrated means without or lost water. The prefix a also means without. So a or an. Anhydrous, like anarchy, it's without rule, right? So anhydrous is without water. These are the prefixes used. These are very similar to the prefixes used in geometry. So especially when we get down here, pentagon, hexagon, octagon, decagon, those are things you're probably familiar with. Mono means 1, di is 2, tri like triangle. Tetra's kind of weird, but tetra means 4. You know the game Tetris? Maybe didn't notice that, but it's little squares which have 4 sides, and all of those weird shapes that are dropping have 4 squares. It's 4s, right? 4s of 4s, Tetris. And then this one's kind of weird for a half, hemi. So you've probably heard of the northern hemisphere. It's the northern half of the earth, right? It's half of a sphere. So hemi is half. So we'll practice here naming these guys. You name the ionic compound exactly the same, and then you use a prefix and hydrate for the water part. So here, CaSO4, what's the name for that part? Calcium sulfate. Does calcium need a Roman numeral? No, because it's in group 2. Group 1A, 2A, 3A, zinc and silver. No Roman numeral. What prefix do I use to represent half? Hemi. It's like right over there on the left side there. So hemi and then the word hydrate, and you stick those together as one word. Now, anybody wondering how you can have half a water molecule? You can't. What this means is that there's 1 water molecule for every 2 formula units of calcium sulfate. But the pattern is when we write these, we write the ionic compound formula, and then we adjust the number of waters accordingly. Because we don't want to say dicalcium sulfate monohydrate. That's just not how we've chosen to do it. So there's no half a water molecule. How about this one? BaCl2 would be barium chloride. Do we need a Roman numeral? No, it's in group 2. We don't use the Roman numeral because we don't need it. We know that the charge is 2. We don't have to tell each other what it is. And then for the hydrate part, hexahydrate. So you should have started making some flashcards and carrying those around with you. These would be good things to put on the flashcards because we're going to use them for other places as well. And then write the formula. Copper 2 sulfate pentahydrate. You got to look at the ions. So copper 2, Cu 2+, that's what the 2 means, the Roman numeral. Sulfate is SO4, 2 minus, because it is. We memorize it that way, right? Here we've got a +2 and a -2. We don't have to do anything fancy. We shove them together, and they'll be neutral. Cu, SO4. And then it says pentahydrate. So a dot, 5, H2O. Any questions?